Hi everyone. In this video session we are going to write a program for multiplication of two polynomials. This video session will treat it as an extension of the two video sessions I did on addition of two polynomials. So if you have not watched those two videos, then probably you should go and watch those two videos before watching this video. But if you are very comfortable with dynamic allocation of structure array, then probably, and with structures and all, so if these concepts are clear, then you can directly watch this video. So in addition of two polynomials, we wrote some functions. One is for reading a polynomial from the user, another is for printing a formatted representation of polynomial on the console, and another is for addition of two polynomials. So all these three functions would require here in this program. So what we would do is we would copy paste all the three functions we wrote earlier into this program, and then we would start with it. So let us copy paste all the functions that we have written in addition of polynomials. So here we have all the code written, and we would also copy the main function as well, because it has got some code for getting inputs from the user, so that we can reuse in this program of multiplication of polynomials. Now we have this addition of polynomials, printing polynomials and reading polynomials, all these three functions available here. We need to make some little changes here in the main function, but rest of it would remain the same. Well, fine. So let us now discuss the algorithm for multiplication of polynomials, and there you'd get to know where addition of polynomials would be required. This function would be required for multiplication. That we'd get to know while we discuss about the multiplication of polynomials. So let us take an example and see how multiplication of polynomials is done, and then figure out the algorithm that we need to implement for accomplishing our task. So let's say these are two polynomials, and how do we multiply these two polynomials is that we take excuse me, let me grab my digital pen. Yes. So here we have two polynomials, and how do we multiply these two polynomials is like this, that each term of the first polynomial would be multiplied with each term of the second polynomial. So here 3x square into 4x to the power 4 would be, first this coefficients of the terms would be multiplied. So this is 3 into 4, that is 12, and then this power terms, this power values would be added. So x to the power 2 plus 4, that is 6. So multiplication of 3x square with 4x to the power 4 would give this term 12x to the power 6. Now plus, now 3x square would be multiplied with 3x cube. So 3 into 3 is 9, coefficients are multiplied, and for multiplying x square with x cube we would need to sum up their powers. So 2 plus 3, here it would be 5. So after multiplying 3x square with second polynomial, this whole of this polynomial, we have got this polynomial. Likewise, we would do this multiplication of each term of the first polynomial with the second polynomial. Here 2x would be multiplied with each term of the second polynomial. So 2x into 4x to the power 4 would give us 8x to the power 5. 2x into 3x cube would be 6x to the power 4. So this is the polynomial that is generated by multiplying 2x into 4x to the power 4 plus 3x cube. Now 5 multiplied with 4x to the power 4 would give us 20x to the power 4, and 5 multiplied with 3x cube would give us 15x cube. Now to get the results, all these three polynomials would be added up. So for adding, we would first have 12x to the power 6. There are no other terms with x to the power 6 as power, so 12x to the power 6 would be written as it is, and then x to the power 5 terms would be added. So here we have two terms with x to the power 5, x to the power 5 as the unknown variables power, and here it would be added up. 9 plus 8 is 17 x to the power 5. So coefficients are added here. Now x to the power 4 terms, there are two x to the power 4 terms, so it would be 26 x to the power 4 and then 1 x cube term, so 15 x cube. So this is the result of the addition of all these three polynomials. So this is what we want, and by if these two polynomials are given as input, this is what we want as output. Now so for multiplying each term of the first polynomial with each term of the second polynomial, we would need a loop. So we would need a nested loop in which the outer loop would run as many times as there are number of terms in the first polynomial, and in each iteration of the outer loop we would multiply a term of the first polynomial with, so we would take a term of the first polynomial, and in the inner loop we would multiply that first polynomial's term with each term of the second polynomial. The inner loop would run as many times as there are number of terms in the second polynomial. So it would be clear while we write the code, but we would require a nested loop for this. Now after each iteration of the outer loop we would get a polynomial like this, right? So after it would be running, the outer loop would run for 3 times, and there would be 3 polynomials that would be generated after each there would be one polynomial that would be generated after each iteration of outer loop, and this has to be summed up into the result polynomial. Let's say we would start with a result polynomial, that is a result array in which we would accumulate the polynomial that is generated in that iteration. So the accumulation statement would go like this: result, let's say this is the array in which the result has to be stored. So whatever content is there in result polynomial or result array, that has to be added with this temporary polynomials. Let's say these are called as temporary polynomials. So each of this polynomial is a temporary polynomial that has to be accumulated or absorbed into the result. So what we would need is whatever polynomial is there stored in the result array, that has to be summed up with this temporary polynomial that has got generated, and the result would be stored back in result polynomial. So in each iteration we would accumulate a polynomial into the result. Likewise, if you do this for 3 times, we would have the final result available in the result array. Well, we would implement it. One thing that we have to discuss is the sizes of this arrays that we would require. So here the maximum size of the result can be m into n, where m is the size of the first polynomial and n is size of the second polynomial. The result could be of maximum size m into n. Why is it so? So if you see, there are m such polynomials, those are getting generated, and each polynomial has got n terms, right? And while we are summing this m polynomials up, and each has n terms, if there is no overlap of the power values of any term with any other term, then there would be m into n terms. So that is the maximum number of terms that the result can have. So let me repeat. If you see, there are three polynomials here. Here the value of m is 3, So here there are 3 polynomials and the value of n is 2, so each of these polynomials is of size 2, and if you are adding this up and if there are no such overlap like we see here x to the power 5 and x to the power 5, if no such overlap are there, then the result would contain all the terms of these temporary polynomials, and that would be 6 in number, that is 2 into 3. So that is what I am saying, that at the max there can be m into n terms in the result polynomial, right? And this temporary polynomials, those are getting generated after each iteration of outer loop. Those would be of size n. So this is what a little discussion about the size of the temporary polynomials and the result polynomial that would get generated. Now let us go for implementation. So we have all these functions ready here. Now we would add a new function and we would call it as multiply polynomials. Void, so it is not supposed to return anything, and let us call it as multiply polynomials, and it has to multiply 2 polynomials, so it would take as input the pointer to the structure array in which the polynomials are stored. So struct polyterm asterisk, let's say the first polynomial's pointer is called as poly1, and then size of the first array of first polynomial, then pointed to the second array, so it's polyterm asterisk poly2, and the size of the second polynomial, and pointed to the result array, the array in which result would be stored. Struct polyterm asterisk result poly. Well, we would write the code here. Now one thing you might should know that this result poly would be of size m into n, or size 1 into size 2, and this polynomial we would dynamically create in the main function that we would do later. Now we will have to write a nested loop. For that we would declare two loop variables ij. Now for multiplying each term of the first polynomial with the each term of the second polynomial, we need to have nested loop, where the outer loop would run as many times as there are number of terms in the first polynomial. So that is 0 to size -1. These many times this loop would run, and within that we would have another loop which would be required to multiply a term of the first polynomial with all the terms of the second polynomial. So for that, this loop has to run as many times as there are number of terms in the second polynomial. So we are starting from 0, we'll have to go up to size 2 minus 1. So the condition is j less than size 2. Fine. So we need to store such temporary polynomials, right, which would be generated by multiplying a term of first polynomial with excuse me, all the terms of the second polynomial. So we need to allocate an array for storing such temporary polynomials. So let us allocate an array first, and we would call it as temp poly. Struct polyterm asterisk, let us call it as temp poly. So this is going to store the pointer to the temporary polynomial for the structure array that we are allocating for storing temporary polynomial. Now we would be using calloc function. So calloc function returns void pointer, so we are typecasting it to struct polyterm asterisk. Now calloc function as parameter takes up the first parameter as the number of elements to be allocated. So here number of elements is equals to size 2, that is the size of the second polynomial. These are the number of terms that this temporary polynomial should contain, and the second parameter of calloc function is size of each element. So here each element would be of type struct polyterm, and the size of each variable of type struct polyterm can be given by size of operator, to which if we pass struct polyterm data type, then it would return the number of bytes required for storing a variable of type struct polyterm, right? So it would allocate an array of size 2 where each variable is of type struct polyterm, and it would return a void pointer to that array that we are typecasting to struct polyterm asterisk and then storing the address in temp poly. Now here we would be using this temp poly array to store the result. So jth term of temp poly would be equals to, so here we need to populate this, we have to calculate this kind of arrays, this kind of polynomials, where we need to calculate the coefficient of the term. The coefficient of the term is given by multiplying the coefficient of the term we are considering of first polynomial with the coefficient of the term of the second polynomial. So here temp poly j dot coefficient is equals to first polynomial's ith term, coefficient of first polynomial's ith term, into second polynomial's jth term's coefficient, and power is calculated by, so jth term's power is calculated by summing the powers of ith term of first polynomial and jth term of second polynomial. Power plus poly 2 j dot power. So let me explain this to you a bit. So here in each iteration we are picking up a particular ith term of the first polynomial, and with that ith term we are multiplying each term of the second polynomial within this inner loop. So for a term of ith polynomial, the first polynomial, ith term of the first polynomial, we are multiplying every term of each term of the second polynomial. So when j is 0, we are actually multiplying the 0th term, that is the first term of the second polynomial, with ith term of the first polynomial, second polynomial with ith term of the first polynomial, and the multiplication is done like this. The coefficients are multiplied but the power values are summed up. So with this we are getting jth term of the temporary polynomial. So after this inner loop we would have this temporary polynomial ready here. Now we'll have to sum this temporary polynomial with the result polynomial, right? This is where, so here we would need to add the polynomial that is stored till now in the result polynomial with the temporary polynomial. Now initially this result polynomial would be having all 0 values. That means every term of the polynomial would look like this, 0x to the power 0, like this. All the terms of result polynomial is containing nothing. So in the main function we would create this result polynomial, the array for storing the result polynomial, and we would pass it in here, right? And we would be using a calloc function, and because of using of Kellogg function, all the bytes of the array that would be allocated would have 0 values. So all the terms of the result polynomial initially would be 0 x to the power 0. Now when the first polynomial is getting generated, we would add this first polynomial with the result polynomial. So the polynomial that we would get would look like this: 12x to the power 6 plus 9x to the power 5 followed with 0x zeros, 0x0, 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 like that for m into n times. So this would be the result that would be generated. Now this has to be stored back in result polynomial. Fine. So here we need to call the addition of polynomials. So this is where addition of polynomials would be required to solve this, to add this temporary polynomial with the result polynomial. So to this add polynomials, we would pass as parameter the result polynomial. Size of the result polynomial, as we discussed, is equals to m into n, or size 1 into size 2. That is the maximum size of the result that could be generated by multiplying two polynomials of size 1 and size 2. And then the next parameter would be the temporary polynomial, and the size of it is equals to size 2, right? Now the last is the array in which, the pointer to the array in which this summation would be stored. Now we cannot pass result poly as that array, even though in this algorithm, in this line, we are saying that result would be stored back in result polynomial, but in calling this add polynomials, we would not be able to pass result poly here, because one thing is that if we pass this array to this function to store the output in, it would overwrite the input. So this would happen, that the input would be overwritten by the output before the input is read and be used for addition. So this is not a possibility. Another thing is that even though all the terms of the result polynomial initially is 0x to the power 0, but add polynomials would be treating this as actual terms, and an addition of a polynomial with m into n terms with this many terms would give a polynomial which would be greater than m into n size, that is size 1 into size 2 size. So for that we need a bigger polynomial to hold this result. So there are m into n terms here, and apart from that we have n terms here. So we would need m into n plus n terms. So we need to have a temporary array in which we can store this result of addition of result polynomial and the temporary polynomial. So let us allocate that array, struct polyterm, and call it as temp addition of polynomials, and we'd copy this expression. Only thing that we need to change here is the size of it. So the size of it would be, so the result here would be of size, that is the addition of the size of the first polynomial, that is size 1 into size 2, and that of the second polynomial. So here the size would be size 1 into size 2 plus size 2. So this would be the size of the temporary array that we have created, and that we would pass into this function, and this is going to return us the result of the addition of result poly with temp poly stored in temp add poly. Now after we are returning back, after the control is returning back from this function, we need to copy the terms of temp add poly back to result poly. And why we are doing this is that in the next iteration we want the the result we have accumulated till now by adding up whatever polynomials we have generated till now available in the result poly, so that the next time again the next temporary polynomial that gets generated gets accumulated, gets added up with the result poly, and the result is stored back into the result poly. So for this, what we would need is we need to copy all the terms which are there in the temp add poly back to the result poly, right? So for that, what we would do is we would have another loop, and for that I am declaring a loop variable, and this loop is going to run size 1 into size 2 times. So k 0, k less than size 1 into size 2 times. So you might question that why size 1 into size 2 times, where temp add poly has got this size 1 into size 2 plus size 2. But if you observe that after this size, after this many positions, all the positions in the temp add poly would be actually 0x to the power 0 and nothing else. It cannot be anything else than 0x to the power 0. Those terms we can just ignore and copy only the first size 1 into size 2 terms into the result poly. So with this loop, kth term of temp add poly would be copied to the kth term of the result poly. So with this, I guess after this loop is done, the result poly would contain the final results, and that we need to present it on the console. Well, so we need to call this function from the main function. For that, we would declare its prototype before the main function that we are doing over here, and we have to make a call to it from the main function. So we have to make a call. So we have this add polynomials here. Instead of that, we are now calling multiply polynomials, and to this we are passing polynomial 1 size 1, poly 2 size 2 result, same as the parameters of add polynomials, but here the result poly would be of a different size. Here if you see, for addition of polynomials we created, yes, so it's already size 1 into size 2. Probably I have done it before starting this video session. So actually for addition of polynomials it should have been size 1 plus size 2. For multiplication should be size 1 into size 2. So this is correct, nothing has to be changed here. So after this is passed, multiplication and print polynomial, and here the size would be size 1 into size 2. So I guess it is done, all done. Now we are ready to test. Hopefully it would build. So it is getting compiled, and hopefully there is no syntactical errors that I have committed. Yes, so there is no syntactical error. Now this is time to test it. Now we would be using the same polynomial that we have used it earlier for explanation. So here the first polynomial has got 3 terms and the second polynomial has got 2 terms, right? Enter coefficient of term 1. So here the first polynomial's terms has to be entered, so it is 3x square, 3x square, right? So coefficient is 3 and power is 2. Now next term is 2x to the power 1, that is 2 1, and 5x to the power 0, right? Now second polynomial is 4x to the power 4, and second term is 3x to the power 3. Now results are shown here. Let us compare it with whatever we have done till now. So it is the result of summation. So I think it is actually running the another program that we have it here. Let us this is bad. So we need to activate this project and we need to compile it first. Yes, so it has got compiled. Now again try with this. So we have 3 terms, 2 terms, then 3x to the power 2, 2x to the power 1, and 5x to the power 0, 4x to the power 4, and 3x to the power 3. Now let us check the results. So here we have 12x to the power 6, right? 9, 17x to the power 5. Somehow this yes, so 17x to the power 5. Here are the results: 17x to the power 5, 26x to the power 4, and 15x to the power 3. So the result is coming out to be perfect. So with this we are done with multiplication of polynomials. Here in this video session we learned the algorithm for multiplication of polynomials, and we reused all the functions that we wrote for addition of polynomials, and to that we just added just a few lines of code to get the results of multiplication of two polynomials. So hope you have liked this video, hope you have understood the logic of the algorithm, and with this you have added to your kitty the knowledge of writing a program for multiplication of polynomials. So like this I would keep on such videos for improving your programming skills in C. So keep watching these videos. Thanks for watching. Bye.